Alright, so we are still talking about refraction, but we didn't get it all done in the first video, so we are going to say that this is refraction. Come on, video number 2. And we were just talking about in video number 1, a convergent lens where the rays of light cross into the lens and get bent downwards or upwards, such that they cross through the focal point, assuming they're all horizontal rays of light. But either way, even if they're not bented so they go through the focal point, in all cases, they're still going to get bent closer towards the focal point no matter what, right? If we picked another one of these, it's going to get bent downwards, it's going to get bent downwards, so it might not get bent so much goes to the focal point, but instead of going off in this direction, it's going to end up going somewhere like this or somewhere like this, right? Because so the top half bends things downwards and the bottom half bends things upwards, right? So that's what we're looking at. And now we want to see, okay, how does this idea of a convergent lens, how does it distort what we see, or how does it change what we see? And in order to do that, we need to look at these ray diagrams. So I'm going to show how we draw a ray diagram in this case. And then in class, we're going to look at it more and see, okay, what are the results of this? When we shine light through it, sure, we can make a ray diagram, but what does that mean in the real world? So I'm going to start drawing this first, and then I'm going to come back and look at the ray diagram. So like I'm saying, and maybe I didn't say it clearly, right? This is going to design to show us what the rays are in the ray diagram. In class, we're going to spend more time talking about what does all this mean, or what is the ray diagram actually telling us, because it's telling us quite a bit. All right. All right, so first of all, let's understand the situation here. We have a lens. It is a convergent lens right here. And there'll be other type, well, there'll be another type of lens. So right now we're dealing with a convex or a convergent lens. And this lens has focal points that are a focal length away. And I'm putting focal points on both sides. And these lengths should be the same, right? If there's this is a focal length of, let's say, 2 centimeters, well, then this is a focal length of 2 centimeters, right? So we draw the focal point in, and we have to go an equal distance or an equal focal length both sides, and we make our mark and say, okay, these are the focal points. Now, these focal points are just spots in space, right? There's nothing there, but that's where parallel rays of light or rays of light that strike it perpendicular to the orientation of the lens would cross. They would cross through the focal point. Now, this object, and I have this object over here is just this arrow, and I could turn it into whatever I want. And, you know, in class, I turned it into, let's see, I think I turned it into a flower. So let's say we had a flower. So I'm going to erase this. There we go. And let's start again. So we have this flower. Here's the stem. Here's the leaves. The leaves. And there it is. Now, this flower is giving off light, and it's not giving off light because it's a light source like a light bulb or the sun. It's giving off light because light is hitting it and light bounces off it. And that's how we see most things, right? If it's not a light source and we see it, which is pretty much everything you see, it's because light hits it and light bounces off it, and then that light that bounces off it, some of it hits your eyes. And the amount of light that hits your eyes is what allows you to see the object, right? So a lot of things we see is because light bounces off it. And for this one, the light that bounces off, and I'm going to erase this in a second, light hits it, and that light just goes in all different directions. And we don't care about most of these directions because it doesn't have anything to do with the lens or anything to do with us. So this light that goes straight up or to the left, that all doesn't matter. We care about the light that hits the lens. So it's a light that goes between there and there, if you will, and these could be straighter lines, but I think you get my point because that's the light that's going to hit the lens. And we're going to be very specific. We're going to pick one spot, and I'm going to pick the very top of this flower. So I care about the light at the top of this flower. Now let me clear all this up just because it makes it very cluttered. So I care about the light there. And again, I'm not concerned with most light. I'm just concerned with the light that hits the lens, and that's still a lot of light. So we're not going to focus on all that light. We're going to focus on the 3 principal rays. 3 principal rays. And if we understand what's happening to these 3 principal rays, then we can say, hey, this is what's going to happen with everything. So it's kind of the point of these videos is so we have these three principal rays, and if we kind of forget how they run, we can go back and look at these videos, right? All the effects of this, we're going to talk about some, but I think that comes out better when we actually set it up in class and say, okay, the principal's rays say that something's going to happen here, and then we go look at what's happened there, and we could see all, we could kind of see the results of the full results of what the lens does. But let's get back to these three principal rays. So the first principal ray is a ray that goes horizontal. Now, before I even draw that horizontal, I want to understand something. We know that the light bends when it enters and bends when it exits the lens. But I don't know if I drew this lens correctly. I don't know if the lens is this thick or anything like that. So we are going to assume we are going to draw this as if all the bending occurred at the center of this lens. So I'm going to draw myself a center line, and let's assume that the black center line is perfect and the lens just isn't drawn perfectly. So we're going to assume that all the bending occurs there, which is okay to assume, and it's just going to make things easier for us. So again, I understand that it bends going in and coming out, but we're going to assume all the bending occurs here so that we could draw this properly. All right, so with that said, ray number one. Ray number one starts here. And ray number one is the ray that travels perfectly horizontal. And we draw it to the center of the lens. And then we've already said that rays of light that come in perpendicular to the lens, so it's a horizontal ray that's striking a vertical lens, will bend through the focal point. So this one I can make go through the focal point, right? And this one I'm probably going to have to freehand it to a certain extent because it's hard to, let's see. And it actually might be better if I don't try and draw this and do this a different way. But it's going to go through the focal point, then it's going to keep on going. Now that didn't go through the focal point very well, so I'm going to pause it, erase it, and draw a better line. All right, so I'm going to start a line there. Come on. I'm going to extend this line. Get out of my way. All right, there we go. Having some issues there, but I think we got it now. And there is my line. So this horizontal ray of light is going to get bent, coming in, going out, so it goes through the focal point. And then I could just take this, and I'll try and do this part with my pen. It's just going to keep on going, right? So it's just going to keep going this way. And I don't know, sometimes PowerPoint wants to do all the thinking for you, and it doesn't know what you want to do. So it's just going to keep on going this way, and it's going to keep going that way till it leaves the paper. All right, so there is ray number one. Now, I don't care if you know them by number. If I was like, hey, tell me which one ray number one is, and you drew one of the other ones instead, that's okay with me, but you should know all three of them, right? If you're like, hey, I called this one ray number one, that's fine for you. Ray number two. Actually, ray number two, I'm going to try and do it a different way again. Ray number two. Ray number two is a line that starts at the same point. They all got to start at the same point, right? That's what they got to do. So it's going to start at the same point, but this is the ray that goes through the center of the lens. So I'm going to draw it to the center of the lens. But I also know, right, the rays at the top of the lens get bent downwards, the rays at the bottom of the lens get bent upwards, and the ray that hits the center of the lens just keeps going straight. So I'm just going to extend this line and let it just keep going straight. There we go. Now, again, I kind of draw it till it leaves the paper if I want. Yeah, that's okay. And I can just put arrowheads on it. That one's just going to keep going till it leaves the paper. So that's ray number two. Ray number two, put it in blue because it's a blue line. That's the second ray. There we go. Ray number three. Ray number 3 again is going to start at the same spot. And we're going to have to draw this one in parts, but let me kind of get a line going. We're going to change the color of it, but it starts in the same spot. And ray number 3 continues, and it goes through the near focal point. And again, we want to stop it, this one, because it's not going to just keep going straight. We're going to stop it at the center of the lens. So ray number 3 goes through the near focal point, and we draw it to the center of the lens. I'm going to try and change the color of that one. We'll make that one green. There we go. So ray number 3 starts at the same place, goes through the near focal point, strikes the lens. Now it strikes the bottom half of the lens, so I know that the rays of light that hit the bottom half of the lens is bent upwards. So how much does it get bent upwards? It gets bent upwards such that it is now going horizontal. It's kind of the opposite of this one. This one comes in horizontal and goes through the focal point. This one's going to go through the focal point, so it's going to come out horizontal, which if you think about it, kind of makes sense because it's kind of bending it the same amounts. I'll move this into position. Here we go. So it's going to start there, and it's going to go horizontal. Come on. Go horizontal. And we're going to change the color of this one, because that is ray number 3. We're also going to do draw. We're going to say that third ray is ray number 3. So there's my 3 principal rays, and as I follow them, I could see how they bend light. Now, the rays of light that I drew, they all don't cross at the focal point, again, because they're not all coming in parallel, but they do cross somewhere. And in a perfect world, they'll cross at exactly one point, and that would be the point. So what does that mean? I'm actually going to erase that dot right there for now. And what I'm saying is that the light that comes off the top of this flower will all cross right there. So there's the 3 principal rays. We're going to do more in class to get a greater understanding of this, but still, these are the principal rays. Those principal rays, if we looked at it in something that, I don't know, my drawing's pretty good, but just to make another one more clear, there they are. This pencil on this side, on the left side, is my object. We have a ray of light number 1 coming in horizontal, bends through the focal point, which is an X. Second ray goes through the center of the lens, just keeps on going straight. Third one goes through the near focal point. When it hits the center of the lens, it is now going horizontal, right? So we're seeing the same type of thing. If this one helps you, the spacing's a little different, so there it is. Right. The second type of lens that we could have is a concave lens. And a concave lens is bowed inward. So it's concave because it's like a cave. It's caved inwards. So again, we can call it concave because of its shape. But like the other one, it's going to have 2. Again, we could say, okay, what if I had this? I had a ray of light that is coming in horizontal up here. We have a ray of light that's coming in. Let's change the color of that one. Sorry. Ray of light that's coming in horizontal in the dead middle. And then we have a ray of light on the bottom that's coming in horizontal. And there it is. We could do the same thing. How does it bend here? How does it bend here? So for this one, the top wheel would hit first. And it would slow down, which causes this whole thing to rotate counterclockwise or make it so it bends upwards. So it would now be traveling more upwards. Then the bottom wheel would come out first and go faster, so it would bend upwards again. So this concave lens, the rays of light would bend up and up on the top. Make the same argument for the bottom, except now down and down. It's going to make it bend outwards, and then it's going to make it, or downwards, sorry, and then it's going to make it bend downwards again. And that ray of light in the middle will just keep on going through the middle. So this is not a convergent lens, right? And it's not a convex lens. So it's a concave lens because it's bowed inwards, and then it's what we call a divergent lens. Because the rays of light diverge on the other side. Now this is like the most common form of eyeglass lenses. If we look at our lens for eyeglass, they don't necessarily look like this, but if we look at it carefully, we could see, are the edges thicker or thinner than the middle of the lens? And for most of us, we have divergent lenses, and the edges of the lens are thicker, and the middle of the lens is thinner. It's caved inwards or bowed inwards, right? And that causes the rays of light to diverge. Now, just to say it and kind of back up a little bit, a convergent lens can generate heat on the other side. If we shine sunlight through this, then that sunlight would all concentrate at that one point. That one point would get hot. If we decided to do that with a divergent lens, well, just the opposite would happen. The light will actually spread out, so in the middle there'd be less light, and it'd actually probably feel cooler than everywhere else because the light would be spread out. So very different, right? Spreads the light out. Now, this still has a focal point, but it's not the same. The rays of light don't cross over here, but what it does have is if I take these points and I trace them back, and this one too, then they'll still all cross or seem to cross at this focal point. So a divergent lens still has a focal point, and it also still has a focal length, but a little trickier, I would say, to a certain extent. So still a focal point, still a focal length. I will say mathematically, the focal lengths of a divergent lens are less than 0, or the focal lengths are negative, right? So mathematically, we treat them as negative, and in some way, we usually have to make it clear what type of lens we're talking about, right? If you buy a camera lens that has a concave lens, right, in some way, they're going to tell you, hey, this is what this lens does for you, because a concave lens is going to do different things than a divergent lens. And we're not even really done with divergent lens. We're just kind of looking at the basics of these. So let's look at a ray diagram. I'm going to pause this and draw this a little better. So let's say we have this, and we have our same flower, or a similar flower. And we want to look at the 3 principal rays for this lens. And just saying this, we're going to have a video 3 certainly, because we're not really looking at, what's the point of these rays, and we're really not looking at what does that mean when the light gets bent these ways, right? We're not really dealing with, how does this actually affect us? We're just trying to get down, the principal rays and how to draw them. And then again in class and in lab, we'll kind of see the effects of these and what does that actually, incorporate to, okay, this is what happens. This is what the 3 principal rays show us, and then what does that mean, right? And that's one of the couple things that we need to deal with, or that's the main thing we need to deal with in class, and we'll make a 3rd video to kind of point out some of this stuff too. But here is my flower, and again, we're going to look at the 3 principal rays. These rays are going to be different because it's a different lens, and they bend light differently, so it's going to have different effects to it, right? So 3 principal rays. And I'm finding not using my pen work better, so let's not use my pen. And let's put the first ray in. And there's 3 rays, and they tend to kind of, again, they're different rays, but they have things in common with each other. We're going to always start them from the same point. And the first ray is still going to go horizontal, and we're still going to draw it to the center of the lens. Now, if we go back, we said, hey, this ray that was coming in horizontal was bent upwards such that if we traced it back, it would cross this focal point. So it's going to be the same thing. So I know that the ray of light will get bent upwards. And how does it get bent upwards? Well, I'm going to kind of line it up, and then I'm going to shift it. It's going to get bent upwards such that, well, it lines up with this focal point and keeps going this way. So this is how I know how to draw the line. Make it a little thicker. And a little thicker. So this is how I draw the line, with the understanding that from here to here doesn't really exist, right? So I don't know if it's going to allow me to erase it, but I'm going to shift it here in a second. All right, so I have this line. And it's not really like that. It's really like Try that again. It's really like that, right? Because there is no light down here from this ray. It's just lined up with this ray. So there's my first one. Now the second one, we'll get another line. Let's bring it over. Second one starts at the same spot, and then that one goes through the center of the lens. And again, from this lens, we know the top gets bent upwards, the bottom gets bent downwards, and the one that goes through the middle just keeps on going through the middle. Let's give that another color. There's ray number 2. And then if we think about it, we're still hitting a pattern, right? We use the center of the lens once. We use the near focal point once. We use the far focal point once, right? If we go back to this one, we use the far focal point, went through the center. We use the near focal point. It's the same type of thing. So far, we've used the near focal point in the center. So now the third ray's got to use the far focal point. So if I'm not sure, we want to keep that in mind. We use the far focal point once, the near focal point once, the center of the lens once, right? Whatever order you say them in doesn't really matter. What matters is that you use all three. So the third ray is going to again start at the same spot. And it is going to line up such that it goes through the far focal point. Again, it's never actually going to get there, but we line it up like this, right? So this is how it goes. I'm going to change the color on that. There we go. But it doesn't ever get there. So really all I'm going to draw is this much of it, right? So that it is lined up still with the far focal point, right? Which works much better with a ruler. There we go. That looks better to me. And then how does that one go? Well, if it's going to go through the focal point and gets bent upwards, it's going to get bent upwards such that, sorry, doesn't want to draw a line again. It gets bent upwards such that it's now going horizontal. So let's kind of make that horizontal and extend it. And there we go. There's my 3 principal rays. I'm going to call this one ray number 3. And again, I'm not too concerned about the order. I'm never going to say, hey, which of these 3 is what we call ray number 3. No, you just got to know that there's 3 and know what those 3 are. So this one's going this way, this one's going this way, and this one's going this way, which in the other one, a convergent lens, we saw where those rays of light converge. And where they converge is very important. That's kind of the whole point of what we're doing. So we're going to definitely look at these sort of things, and we're going to talk about these in the next video. But if I look at these, the rays of light don't converge, right? They actually diverge. They spread apart. So it's not going to give me the same type of image. This is going to give me what I call a virtual image, and we'll talk about virtual images more later. But we won't see the image in the same way as the last time. So where is the place where these 3 cross? Well, if I do this, and I trace this line back, and I keep tracing it back, it's going to be like this. I'll make it a dotted line, and then I insert another one, and I trace my green line back. Which means just horizontally. So I trace this one back. It's slightly off, but it's not much off. And then I trace the orange one back, but the orange one is just a straight line. So tracing it back, I'm staying on that line. Then all of a sudden I see that these 3 rays of light, they don't actually cross here. But let me try and make this clear as I wrap this up. If I was sitting over here and I was looking at the flower, I was looking at the flower through the lens, right? Then I wouldn't see these rays. I would see these rays because these are the rays of light that leave the lens. So these are the rays of light that, this is like how the light would be traveling if I was over here looking at it. And what it would seem like to me is not that the flower's over here and the light's coming here. It would seem like these lights, these three rays and all the other rays, well, it would seem like they originated from over here. So when I look through the lens, the flower would seem like it's there. Now, it's not actually there. It's an image of it, right? And images are a big deal. But what we would see is what we call a virtual image, and we'll get into that more. What we'd see is a virtual image. And the only way I see this virtual image is if I'm over here looking through the lens at the object. And then the object would appear, in this case, much smaller and closer. But again, these are the types of things, there's enough already in these videos, so we're going to talk about those sort of things more. Again, this is more so we could see the principal rays and not all the overall results of these principal rays. If you don't like my drawing, which I think is probably better than this one, then it looks something like this. Horizontal up, so it lines up with the focal point through the center of the lens and just keeps on going towards the far focal point. And then when it hits the lens, it gets bent upward, so it goes horizontal. Trace those back. They all cross at one point if you did a good job. All right, so those are the three principal rays in this video. And again, we need to talk about the implications and what does that actually mean when you use these lenses.